Welcome to Talkin Science, where we dive into the stories making headlines in the world of science and space. I'm Matt Miller. Dr. Brad Tucker is here. Brad, happy Tuesday.
How's it going?
Really good, my friend. Let's get the headlines in this, the 31st week of 2021. Light has been detected bouncing off a black hole, proving Einstein right again. The new Russian module sent to the space station spinning in a hair-raising hour for the 20-year-old outpost. And Rocket Labs returns to flight 2 months after a catastrophic failure to launch. Well, before we get into the show, Brad, a quick reminder of the socials. We can find you on Twitter at btucker22. I'm on Twitter at Miramat86, and of course, Trekzone exclusively on Twitter. Plus, find our YouTube channel for the latest eps and on your podcast app of choice. And you can get behind-the-scenes goss and early access to all Trekzone podcasts by becoming a member today. Click the join button on any Trekzone video, go to the trek.zone/support, and put your phone up to the QR code on screen throughout the show. Brad, first up in our headlines, Starliner's second uncrewed test flight has been postponed until the middle of this week.
Yeah, after the incident with the Russian module, they said essentially, hey, too many things going on at once, rescheduled it for a few days later, scheduled to take place Wednesday morning Australian time, so it's just about 24 hours from now. So hopefully it all goes according to plan, as we talked about last week.
Absolutely. Well, Saturn's at opposition, making for some perfect astronomical viewing opportunities.
Yeah, that's right. It is, it's a great chance to go outside and see Jupiter and Saturn, very bright in the sky, visible all evening. So it's a really great time to look up. Enjoy some hopefully clear winter skies.
Absolutely. Well, let's get into the stories of the week. And new research has proven Einstein right again, Brad.
Yeah, this is kind of what we call another aspect of the massive gravitational force, essentially, or energy that these black holes have. And that is that they're able to create what we call light echoes, or glimpses or flashes, in this case of X-ray light, that have come from behind the black hole, and through the gravity of the black hole been able to actually been essentially bounced off or really echoed or visible, when previously you wouldn't really be able to see it because it's trapped behind the black hole. Black holes being actual spherical objects, not just kind of circles in space.
Well, a supermassive black hole, 800 million light years away, has given us this rare insight, and it's in the form of X-ray flashes.
That's right. So, black holes are spinning, and as they're spinning, they create the magnetic field around the black hole creates huge amounts of energy that actually produces very high energy types of light, X-ray light. X-ray light is actually very energetic, kind of why we can see through you to see your bones when you need one. Well, so in this case, because of the immense energy from the magnetic field and the spinning, it produces these flashes of X-ray light. And now we've seen these X-ray light flashes before. That's not what's necessarily new, but is actually seeing one from behind the black hole, when normally the black hole itself would obscure or really block any of that light.
Now, while we've seen light bending around a black hole before, this is the first time that astronomers have captured it from the other side, as you say, seeing through this black hole.
Yeah, so usually what happens is anything that has a lot of mass, we call these lenses. So the gravity can bend light around it. So we see light traveling through and bending around a black hole. We see galaxies and even stars. But as you said, in this case, it's right essentially from behind the black hole. And so it's actually, that's why we're calling it almost bouncing off the black hole, that it's, instead of the light being sucked into the black hole as we normally think, that the energy has actually bounced it around the black hole again being this spherical object, and producing this flash of light towards us. So really seeing kind of the immediate behind of the black hole rather than something further away.
NASA's Nuclear Spectroscopic Telescope Array and the European Space Agency's XMM Newton telescope were key to these discoveries, once again showing that international cooperation is key to better understanding the universe, Brad.
Yeah, and it's also one of these things that, we talk quite a bit of black holes because there are so many different ways now of that we're studying them and understanding them and what we can do, and really the importance that this shows, of what astronomers do is you can't just look in the visible light, that there's so many other ways of seeing things in space, and especially in black holes, that otherwise you would kind of miss these otherwise invisible things to the colors of eyes or just can see. And that's why some of these X-ray telescopes have been built, and even new ones being planned, because they can see very high energy, very energetic things in the universe that normally we couldn't see with other colors of light.
Very exciting stuff indeed. Well, in some pretty serious news, Brad, the space station spun out of control for about 50 minutes last week after the new Russian module fired its thrusters unexpectedly.
Yeah, we were talking about this last week when the module was on its way to join in. But as you said, it kind of went to a very scary place, that as the docking happened with the new module, so it was the astronauts inside who were essentially guiding it in, kind of parallel parking it. Once it docked, for some reason, the thrusters from the Russian module kicked on. And that caused the Russian module to spin. But because it was docked with the International Space Station, it caused the entire space station to spin. And it really was a pretty hairy, as you said, just about an hour as this whole thing played out. So they had to stop the thrusters from the Russian module and then reverse the thrusters by using thrusters from the International Space Station, which it does have. So it was a very tense, as you said, hour as this whole thing was supposed to be a fairly routine process.
Well, Roscosmos say it was a computer glitch. NASA said the station tilted about 45 degrees, but flight director Zebulon Scoville, told the New York Times it was far more serious, that this is the first spacecraft emergency that he's ever declared, and that the station tilted 540 degrees or 1.5 revolutions. Some pretty serious stuff, bro.
Yeah, that's exactly right. And as you said, if it really did, instead of just 45, but do a whole full spin and come around, that is a lot, and that is the worry of just how fast. It's one of these questions that people are raising. Well, how fast can the space station spin before things go bad or pear-shaped? And obviously, they never got to that point, which is good. But it was a sort of worry that they had that it could again go pretty catastrophically wrong if they were not able to stop and then reverse the effect from the space station. And as you said, essentially what appeared to be mostly a computer-driven glitch is a bit scary to think what else could have been wrong. And again, luckily no one is injured and there appears to be no damage to the space station. But again, it just goes to show that even seemingly innocuous routine things can go pear-shaped.
Yeah, absolutely. Well, Scoville also said that what was thought to be erroneous code turned out to be a critical incident unfolding, with the module not only firing its thrusters, but that it was trying to pull away from the station as well. The only hope of stopping it was a Russian ground station that was an hour away from comm range. The rotation rate, though, was only 0.56 degrees per second, so imperceptible to the astronauts aboard, but still a situation needing to be resolved, and it has been resolved now, thankfully.
That's right, exactly. So again, luckily, all is solved, all is fine. But when we talk about private space travel, when we talk about humans and astronauts and tourism going into space, it's all these little things that go wrong and why these astronauts are trained the way they do. This is one of the examples. This is the reason they go through all of this work. It's because there is a lot of work that can happen. There is a lot of stuff that can happen, and they have to prepare and train for it. And, this just kind of highlights that need and that effort that has to go in for this sort of stuff.
Absolutely. Well, lastly, this week, Brad, Rocket Lab has successfully launched a satellite to perform research and development for the US Space Force in a return to flight, 2 months in the making.
Yeah, that's right. Obviously, they were a bit delayed after some previous missions, as he said, and one that they've wanting to get off for quite a while. But as you said, quite a critical program to test U.S. defense satellite launching. Again, this is going to be, this is one of their big customers, which means, you not only just want to keep them happy, but when you have, in any of these cases, regular customers that are using you, the model for all of these groups, SpaceX, Rocket Labs, whoever it may be, is obviously you add lots of other satellites on board. So keeping these customers through means the other companies or groups who launch satellites are very easy or have easier options or more options to get into space. So a very important test to get done. And obviously said they've been really wanting to get back to action since their anomaly that happened in May.
Now, I love Rocket Lab's naming scheme. This mission, it's a bit chilly up here. It launched on the 29th of July and saw another successful launch of their Electron rocket. This one in particular has been flying since 2018. Just incredible use of reusable technology.
Yeah, exactly. That's right. They're getting multiple launches out of theirs. And look, I agree. Like the fact is they have quite a good naming scheme for their launches. I wonder how long they'll be able to keep it up, but more power to them for adding some spice, as it were, to their launches.
Yeah, absolutely. And as you mentioned just before, customers for this mission, it's a rideshare operation, the US Department of Defense Space Test Program, the Rocket Systems Launch Program, as well as a partnership with Rapid Agile Launch Initiative Defense Innovation Unit. That's a mouthful. All of whom, they're based in the USA. Ride sharing into space. We love to see it, Brad. It really does drive down the cost of launch.
Yeah, and it's just the way that stuff has to happen. It is the thing that makes it easier. And it's no different. And this is kind of the point where space is happening. We don't have to think of space as a dramatically different world to how we do operations here on Earth. You do shipping the same way, you do transportation the same way, you do backloading, and this is the same view of space, is doing it the same way. You don't have to have a one built, one customer, one ride system. It is these agile systems that can do a lot, take a lot, and work quite often and reliable. That means space is accessible, therefore bringing those costs down, which means the cost of the satellites come down, which means the costs who use them come down for those people. And that really is the consumer at some point, whether it be through the US government or even just a private company or the average person who ends up using the technology or the data from that satellite.
Absolutely. And this launch means the third failure in May overall for Rocket Labs is likely the abnormality, meaning getting into orbit is something Rocket Lab can bounce back from and do quite successfully. This now puts their odds out to 1 in 7, which is very good for rocket science.
Yeah, look, it is hard, but as you said, it's one of those things that, I mean, think of how many times an airplane has a mechanical failure before it takes off, and so they don't take off. When you do volume, you're going to have issues. And so what they're showing is that there's not a design flaw. This is not a regular problem. It was an abnormality. And more importantly, as you said, they can get back online quickly. Obviously, they want to do due diligence to make sure they understand what went wrong and why. But that means that it isn't a fatal flaw or requiring an overhaul of anything. They can bounce back, as you said, quickly, which is the key for groups, is often and quick access to space.
Absolutely. Well, just before we go, Brad, a look ahead to this week's Talkin Science continuation. After a hiccup last week, Talkin Science Quick Takes will launch. Look out for a double header of our look into Enceladus's subsurface ocean and primitive meteorites as well. They'll be out on Thursday at 12:30 p.m. GMT. Or if you're watching us in the future, click the card in the top right of the video as each of them happens here on YouTube. Or follow the links to our website at Trekzone.org if you are listening to this as a podcast. Brad, great to pick apart the stories of the week with you. We'll do it again next week.
Sounds good.
Keep up to date with Twitter. Catch new podcasts daily on YouTube. Plus, we're beaming to your favorite podcast app 5 days a week. Just search for Trekzone and subscribe.